Okay, day 11, section 2. So we've talked about here in the first section of lecture today how the Fed controls the monetary base, right? And the Fed controls the monetary base through open market operations or through discount loans. And when they do that, they change the amount of currency or reserves in the banking system. But remember, the monetary base is not the same thing as the money supply, right? So how does a change in the monetary base impact the money supply? That's what we want to talk about here in this next section of lecture. All right, so how does a change in the monetary base change M1? So let's work through a very, very simple example here. Let's assume that the Fed creates $100, right? And just get this a little bigger. The Fed creates $100 and Jerome Powell, chairman of the Federal Reserve, gets up in the golden Fed helicopter and goes flying around the world and, goes flying right over Mount Vernon and drops that $100 bill right on the campus. And President Brand, the lucky bastard, happens to be walking around and falls right into his lap. He's like, hey, I've got $100. What am I going to do with this, right? Well, what's he going to do with it? Let's say that he goes out and he buys a tiger, okay? It's been a dream of his based on his Netflix watching recently. So he buys a tiger and he takes that money, buys the tiger. The tiger breeder deposits that money at the end of the day, and it ends up in the banking system. Now, in our assumption, we're going to assume that banks have to hold required reserves of 10%. Whenever a bank takes in a deposit, they have to hold 10% of that as deposits. I'm sorry, 10% of that as reserves. And let's also assume that banks don't hold any excess reserves. So whatever money they take in, they want to lend out. So let's think about this. Let's say that the tiger breeder banks at First National, right? Wait, I'm sorry, I'm reading this. No, let's assume that the tiger breeder banks at Bank A here. So now this bank has $100 or 100 million. We'll just drop the million. $100 in new deposits. How much of that money can this bank lend out? Well, the required reserve ratio is 10%. So what that means is that of that $100, they have to keep $10 as required reserves, and $90 becomes excess reserves. But as we said before, banks don't like excess reserves because that's really money that's not earning them any return. What do they want to do? They want to lend that money out, right? They want to lend that money out. So Bank A lends that money out. Let's say they lend it out to VP of Student Affairs, John Harp, who wants to spend that $90 in getting some hair plugs so he can get a mullet that he can frost platinum. So John takes a loan, he gets the mullet, hairdresser deposits that money at their bank, Bank B. How much in new deposits does Bank B get? They get $90. How much of that do they have to keep as required reserves? 10% of it, or $9. So that $9 they send to the Federal Reserve to keep as required reserves. What does that mean? That the bank then has $81 as excess reserves. But the bank doesn't want to hold excess reserves because that's not money that's working for them. So what do? They lend it out, right? And then it goes to Bank C, right? And Bank C just goes to some other nameless member of the Cornell community who wants to do a murder for hire. Maybe my example's gone off the rails here. Forget the murder for hire. But Bank A, once the $81 has been lent out, it's going to end up in another bank, and it's going to create $81 in deposits for them. How much of it is required reserves? $8.10. Meaning how much is in excess? $72.90. What's the bank going to do? They're going to lend that out. And notice here what's happening. New deposits creates new lending, which creates new deposits, which creates new lending. In the end, though, look what's happened to the number of deposits. While the Fed only created $100 in new deposits, look what happened when you add all this up for all banks. It created $1,000 of new deposits. In other words, while the Fed changed the monetary base by 100, the money supply, which is currency plus deposits, changed by 10 times that. And this is what we call the money multiplier. The money multiplier here simply says that the change in M1 is going to be bigger than the change in the monetary base. The change in M1 is bigger than the change in the monetary base. Why? Because new monetary base leads to new deposits, which leads to new lending, which leads to new deposits, which leads to new lending. This process gets multiplied in the banking system. Okay, so you can think about the relationship in this way. Whatever the monetary base is, you have to multiply it by the money multiplier to get what M1 is. So in this example, if the monetary base is changed by 100 and the money M1 changed by 1,000, the money multiplier is 10, right? Meaning the change in the money supply is 10 times the change in the monetary base. Can we derive mathematically how big this money multiplier is? Yes, we can. And ordinarily in class, I would do this up on the board and kind of work through the algebra of this. In my notes, I have the algebra here for you. I'm not going to ask you about this on the exam. And so it feels very awkward here on Zoom to kind of work through the algebra. So I'm just going to kind of, if you're interested in how this works, let you kind of look through this. But I'm just going to kind of jump to the conclusions. So let's define two new variables. Little c, which is basically what we call the currency to deposit ratio, right? The total amount of currency divided by the total number of deposits. That's the currency ratio, or I'll often call it the currency to deposit ratio. And then little e, meaning the excess reserves to deposit ratio, okay? So little c is just currency relative to the size of total deposits, and little e is excess reserves relative to the size of total deposits. So if you use our definitions here of the monetary base and of M1 and of what total reserves are required reserves and excess reserves, and then you note that required reserves are the reserve requirement ratio times deposits. So if you use these four definitions that we've talked about before, you can use a little bit of algebra, skipping through, and what you're going to come up with is this. That M1 is equal to this function in the brackets times the monetary base. In other words, this function in the brackets is the money multiplier. The money multiplier is 1 plus little c divided by little r, which is the reserve requirement ratio, plus little e plus little c, okay? So this is basically algebraically how you can figure out how big that money multiplier is. So this tells you when the Fed changes the monetary base, how many more times will M1 change? So let's just do a simple numerical example here. This is actually a numerical example that's designed to be somewhat realistic, right? If you look at the US today, what is the reserve requirement ratio? Well, we'll talk about this a little bit tomorrow. It's not a simple number, but it's close to about 10%. Using 10% is probably a pretty good rough estimate. So let's use the required reserve ratio of 10%. Before this crisis, I don't know what this is today. This has almost certainly changed, but back in January, the currency in circulation in the U.S. is about $400 billion. Deposits were about $800 billion, and excess reserves were about $0.8 billion. The money supply then is M1, C plus D, currency plus reserves. So these two numbers together of 1,200 billion. right? What is the money multiplier? To use the money multiplier, we have to figure out little c and little e. Little c is currency divided by deposits, 400 divided by 800, or 0.5. The excess reserve to deposit ratio is 0.8 divided by 800, or 0.001. The money multiplier then is just 1 plus c divided by r plus e plus c, this equation. So 1 plus c divided by r plus e plus c. Plug that in, and what you find is that the money multiplier is about 2.5. So if the Fed changes the money multiplier by 100 million, the money supply should change by about 250 million. It should change by 2.5 times that. Okay, so that's the money multiplier, right? That's the money multiplier. And if you notice here, this actually means that the Fed has a lot of power to control the money supply, right? It has a lot of power to control the money supply. When the Fed changes the monetary base by a little, it can change the money supply by a lot. Having said that, does the Fed have perfect control over the money supply? No, because the Fed doesn't control this money multiplier. Right? The Fed doesn't control this money multiplier. Specifically, notice the things that reflect the money that change the money multiplier. The reserve requirement ratio, right? Little r. The Fed does control this, right? This is the part of the money multiplier the Fed does control. If the Fed would raise the raise the reserve requirement ratio, it would lower the size of the money multiplier. And I think if you think about this for a moment, that makes sense, right? If the Fed requires banks, whenever they get a deposit, to hold more of it in reserve and lend less of it out, you're going to get less of that cyclical effect, right? You're going to get fewer loans, which is going to create fewer deposits, and you're not going to get the multiplier effect nearly as big. This is the part of the multiplier that the Fed controls. But the next two parts of the multiplier, the Fed does not control. How much do people want to hold currency? Notice that if people hold more currency, that's also going to reduce the multiplier, right? Because money that's held in currency is not money that's held in banks. So if people decide they want to hold big wad of dough and don't deposit their money, that's going to reduce the size of the multiplier. And the Fed doesn't control this, right? The Fed doesn't control this. Likewise, the Fed doesn't control how much excess reserves banks want to hold. If banks get scared and they don't want to lend money out, right? This should be, I'm sorry, little e, not little r. If banks decide that they get scared and they don't want to lend money out, they're just going to hold excess reserves, that means less loans and less money created. And so that will also reduce the multiplier. So the Fed controls the monetary base. They do not control the money supply. Why? Because the Fed doesn't control the multiplier. Specifically, the Fed doesn't control how much excess reserves banks hold and how much currency the public holds. So you'll hear me use this analogy a lot, if I haven't already used it a lot in this class. But you have to think about the Fed controlling the money supply like I walk my dog. All right, so you just heard my dog bark in the previous section. Not the world's most well-behaved dog. When I take her out for a walk, she's kind of all over the place, left, right, okay? At any given moment, do I know where my dog's gonna go? No, I don't have perfect control over the dog. But in the long run, do I control where the dog goes? Yes, because I have her on a leash. And so when she starts to wander a little bit off, I yank her back. Right? And that's kind of how the Fed manages the money supply. On a day-to-day, week-to-week basis, the Fed really has no idea what's happening to the money supply. It's all over the place. And, particularly, we're talking about turbulent times right now. I know that the Fed is struggling with trying to manage the size of the money supply on a day-to-day basis. But over the long run, the Fed's going to control the money supply. The Fed is going to yank it back. If the money supply is growing too fast for them, they'll find ways to slow it down. And if the money supply is growing too slow, they'll find ways to try to kick it up, right? But the Fed doesn't have perfect control over the money supply, and that's very important to remember. So let's take a break here, and we'll come back with the final section and talk about a couple of examples of when the Fed struggled to control the money supply.